Hi guys, this is Saurav here and welcome to another session of JEE Aspire Advanced for the JEE Main Advanced 2019. This session is primarily meant for those people who were quite afraid of electrochemistry. We have been conducting a number of such sessions for physics, chemistry and maths, and as you know, the last two sessions on chemistry were on liquid solutions. I had divided sessions into liquid solutions 1 and liquid solution 2, and electrochemistry has also been divided into two such sessions. Liquid solutions was an important topic and we had covered substantial amount of content related to ideal as well as non-ideal solutions. So I would request people who haven't watched those videos to review them, because they would help you to do really good in the forthcoming mains examination as well as the advanced examination. Okay, also this session is calculation intensive, so I would request you to sit with a pen and a paper, and a non-programmable calculator will be fine, and solve the questions simultaneously with me. People who don't know me, I am Saurav Goswami. I have been teaching IIT JEE for about 10 years now, and I am from NIT Rourkela, and this is my session for electrochemistry. So sit back and enjoy the session. The first thing that we need to know in electrochemistry is a fairly easy topic and may appear challenging because it takes cues from so many things. It takes cues from ionic equilibrium, it takes concept from chemical equilibrium, it takes concepts from redox reactions, it takes concepts from thermodynamics. So इन सारे chapters का mixture है ये. Okay, so घबराना नहीं है इसमें. करना क्या है? You have to just be a little thorough with all of these topics in bits and pieces. Also, there is only one equation that you have to remember, that is Nernst Equation, and that will help you solve probably almost like 90% of the question. 10% of the questions ऐसे होते हैं जिसमें कि Nernst equation की जरूरत नहीं होती है, and you just have to evaluate it on the merit of the question. Okay, so they will be like different, some kind of an arbitrary out of the box question. But when you're going to write the JEE Advanced examination, don't worry about like arbitrary out of box questions. Focus more on whatever is there in the portion and prepare yourself for that. Okay, so let's start the session with the first question, and the first question is really interesting. The first question is this. The first question talks about something known as a Latimer diagram. Please look at the question. It's not a very calculation intensive question, however it's a very conceptual one. So use the following Latimer diagram to predict. So this is a Latimer diagram. Now what is a Latimer diagram? A Latimer diagram lists the oxidation states of an element from the most oxidized to the most reduced using its electrode potentials, and in this scenario we use the reduction potential because वो oxidize से reduce की तरफ जा रहा है. So you can see that permanganate over here is going from MnO4 minus MnO4 2 minus MnO2 Mn3 plus Mn2 plus to Mn all the way to Mn. So all these values that you can see above the arrows, these are not commas, these are decimals. So all these values like 1.7, 0.56, 2.26, all these values that you're seeing in terms of volts are standard electrode potential values. Standard electrode potential values. Now these values are measured either in the acidic medium or in the basic medium, that we do not have to worry about in this question or any Latimer diagram. But Latimer diagram is usually utilized to list all of these things in one place to concise the content. Okay, बहुत जगह लिखने की जगह हम एक जगह लिख देते हैं. So most oxidized to least oxidized, most oxidized to most reduced form. So question is, how you have to identify how many Mn species would undergo disproportionation. Now disproportionation is something that you had read in redox reactions, and disproportionation is known as a redox reaction in which simultaneous oxidation and reduction of the same species takes place. For example, so a disproportionation reaction is like this: Br2 that changes to Br minus and BrO3 minus. The reaction takes place in basic medium, but that's not important. Why is this known as disproportionation? Because if you look at the oxidation state of bromine, this is 0. Oxidation of bromine over here is -1. Oxidation of bromine in BrO3 minus is +5. So bromine is undergoing reduction over here, while bromine is undergoing oxidation in this case. So disproportionation ये होता है जिसमें कि same element simultaneously oxidize या reduce हो. Now any oxidation reduction reaction couple generates something known as a cell potential. They can combine to become a cell, because a cell is composed of a redox change. A cell is not only oxidation, not only reduction, it's a oxidation half reaction and reduction half reaction combined together to form a electrochemical cell. Now I have to identify that which species undergo disproportionation, and how do I do that? The method is very simple. Let's understand a simple concept. The concept is this. Suppose you are given two types of reactions. I'm discussing this because it is generally a confusion for most of the students. Suppose we have two reactions. Case 1, where a reaction takes place where A changes to A plus, gives out an electron, and B takes up this electron to change to B minus. Okay? Now, if you see a redox reaction and the E naught value for this is given as 1.1 and the E naught value for this is given as 0.5. So what you have to do is you just have to directly add them. Okay, you do not worry about E naught for the cell is 1.6. Do not worry about how many electrons are given out. This is case 1 in which the number of electrons given out or taken in are equal. What if the number of electrons given out or taken in are unequal? For example, case 2, A changes to A3 plus and gives out 3 electrons, while B takes up only 1 electron to form B minus. Now it's a major mistake that the students do, that what they think is 3 electrons are given out over here, so I have to multiply whatever cell potential that I have with 3. Let's say the cell potential over here is given as 1.5. The cell potential over here remains the same. I'm sorry. You have people think that you have to multiply the oxidation and the reduction potential. So E naught for oxidation potential is, let's say, 1.5. E naught for reduction potential is 0.5. Also, yeah, 0.5. Let's say it is these values. Now, even if unequal number of electrons are given out, as long as it is redox, do not worry about the number of electrons. Do not worry about the number of electrons. Okay? As long as it is redox change, do not worry about the number of electrons. Add both of them. That will be your answer. That will be your answer. Okay? If it is unequal number of electrons or equal number of electrons, do not worry about that. Add the half cell potentials or oxidation reduction potentials. But if it is a scenario where it is only oxidation or if it is only reduction, for example, let's say A changes to A plus changes to A2 plus. You have been asked to identify how much is for A changing to A2 plus. This is to be calculated. This has been given as, let's say, oxidation is given as 1.1. E naught for oxidation is given as 1.3. Let's say these are some dummy values. You have to identify what is the E naught for oxidation for this. Okay, now in such a scenario, you can see that the entity is not undergoing a redox change. It is only undergoing oxidation in each of them. So what you can do, you can derive the third equation by adding the first two equations. And these two equations do not add up to become a redox change. So if it is adding up to become a redox change, आप cell potentials को directly add कर सकते हैं. But if it is not adding up to become a redox change, then you have to use the free energy method. And the free energy method is that we know that delta G is equal to minus NFE. So हमको ये करना क्या है? It is very very simple. For this I will write, for this reaction I will write delta G1, which is equal to how many electrons are given out? 1 electron. So delta G is minus 1 times F times 1.1. For this I will write delta G2, which is minus 1 F 1.3. For this I will write delta G3, which is equal to delta G1 plus delta G2. Both of the reactions are being added to get this. For delta G3, the number of electrons lost is equal to 2F E, which you need to calculate, and this is 1.1. I can write minus 1 F common, 1.1 plus 1.3, that will make it equal to 2.4. Okay, this gets cancelled out, this gets cancelled out, minus gets cancelled out, and E becomes equal to 2.4 by 2, that is 1.2. Is this clear? So please don't add them directly. If you had added it, you would have obtained a value of 2.4, but the value is 1.2. So remember this, only if the cell reactions, half cell reactions add up to become a redox change, you are allowed to add them. But when they are not turning out to become a redox change, they're only turning out to become either complete oxidation or either complete reduction, then you have to use this free energy method. Okay, also, how do we identify if something disproportionates? When any entity disproportionates, the substance undergoes simultaneous oxidation and reduction, so the total cell potential should be positive. For a feasible reaction, delta G should be negative. If delta G is negative, E value should be positive, or E cell should be positive. Okay, so if E cell is positive, the process is feasible. Let's apply the same concept in the previous question or in problem number 1. So let's start with MnO4 minus. MnO4 minus is a species which can only undergo reduction. Can we agree on that? Because it is in the highest oxidation state, it cannot lose any more electrons, it can only undergo oxidation. So this is not our answer. Let's look at MnO4 2 minus. MnO4 2 minus can undergo reduction through this potential, but also it can undergo oxidation by reverse of this. So if I want to write MnO4 minus disproportionating, I will write that it is simultaneously changing into MnO2 and MnO4 minus. Sorry, this is 2 minus, it is changing into MnO2 and MnO4 minus. Why am I saying this? That because this species can change into this form, which is the oxidized form, which is the reduced form, and this is the oxidized form. Okay, for this entity, this is the reduced form and this is the oxidized form. If both of them are formed simultaneously, then what I'll do is, I will take the cell, this value will become the E for oxidation half cell, this value will become the E for minus of reduction half cell. The reason is, backward it will become minus. Okay, so the reverse of this will become reduction half cell. So what I'll write is, this value becomes equal to 2.26 minus 0.56. This value turns out to be positive. So MnO4 2 minus can undergo disproportionation. So the species would be MnO4 2 minus. Let's evaluate the next one. MnO2 0.95 reduction minus 2.26 oxidation. Sum of these two will be a negative value, 0.95 in this direction. Backward direction will be oxidation. So this value is written for reduction of this. So reverse of that, minus 2.26 plus 0.95 will be equal to the cell potential if this undergoes disproportionation. Then that value will be negative. So this will not undergo that process. Let's look at Mn3 plus. Mn3 plus 1.51 minus 0.95 positive. Mn2 plus minus 1.18 minus 1.15 negative value. No, not possible. Mn can only undergo oxidation, so this is also not possible. So MnO4 2 minus and Mn3 plus can undergo disproportionation. So remember that we have to when you go in the backward direction, you have to put a negative sign in front of it. When you're going in the forward direction, you'll take the value as it is. So we have two species which will undergo disproportion number of Mn species, so the answer will be 2. What is the E naught value for the conversion of MnO2 to Mn2 plus? MnO2 to Mn2 plus, can you see that it is complete oxidation, and this oxidation is completely utilizing this reaction as well as this reaction. So this whole reaction MnO2 to Mn2 plus is made up of two half oxidation reactions. Should we use the E cell method? Can I add both of them? No, because the complete reaction is not a redox change. We are adding two oxidation reactions. We have to add two oxidation to get the third oxidation reaction. So how do we do that? So the answer for this was 2. The answer for this was 2. For this, how would we write? MnO2 changing into Mn3 plus and Mn3 plus changing into Mn2 plus. How many electrons are lost or gained? What is the process? It is undergoing reduction. So electrons are being gained. How many electrons are being gained? Mn is in plus 4 changes to plus 3, 1 electron. Plus 3 changes 1 electron. I have to calculate it for the overall. MnO2 changes to Mn2 plus. This takes up 2 electron. So how would I write? Delta G for the overall reaction will be equal to the delta G value for this plus delta G value for this. So delta G for this reaction would be written as delta G1, which is equal to minus F value is 0.95. For this it will be written as minus F 1.51. For this it will be written as minus 2F, the value E which we need to calculate. This is very simple. This we had discussed earlier. So how do we solve it? We equate this to the sum of these two. What we would obtain is E is equal to 1.51 plus 0.95. So that turns out to be 6, 9, 5, 14, 2.46 by 2, that is 1.23 volts. Okay, that explains our question. Okay, it's a slightly lengthy question, but I had to give you a bit of theory so that when we move to the next questions, you do not feel scared, or you never feel scared when you see a question like this. Okay, let's move on to the next question. Okay guys, so let's look at the second question. The second question tells us that a cell contains two hydrogen electrodes. The negative electrode is in connection with contact with a solution of 10 raised to minus 6 molar H plus ions, and the EMF of the cell is 0.118 at 298 Kelvin. What is the pH of the solution at the positive electrode? Now, positive electrode and negative electrode in electrochemical and in electrolytic are different. Positive and polarity does not cause a electrode to behave as an anode or behave as an cathode. It is the reaction which makes it behave as an anode or a cathode. जैसे कि अगर एक electrode पे oxidation हो रहा है, I'll call it a anode. If there is reduction taking place, I'll call it cathode. But the polarity of the anode in an electrochemical cell is negative, and that of a cathode is positive. It is exactly the other way around in an electrolytic cell. So let's try and work out this problem. The negative electrode is anode that we are talking about, and positive electrode is the cathode that we are talking about. And since it is a hydrogen electrode को हम इस तरह से लिख सकते हैं. At anode, the reaction must be like this. At anode, the reaction must be like this. Hydrogen is undergoing oxidation. I will write it like this. H plus giving out an electron. Okay, I can write the Nernst equation for this very easily. Nernst equation for this will be written as E for oxidation half cell, because this is the oxidation half cell, this is the part where oxidation is taking place, is equal to, since this is the standard hydrogen electrode, I can very well say that E cell will be equal to 0, क्योंकि reference उसको लेते हैं, reference electrode, और ये 0 मान के चलते हैं. So I can take it as minus 0.0591 by 1 log of H plus ion concentration by hydrogen to the power 1 by 2. It's very easy. I can further simplify 0.0591 by 1 log of hydrogen's pressure is not given, so I'll consider it to be 1 atmospheric pressure, because जितने pressure पे oxidation half cell is present, the same pressure is present in the reduction half cell, because that's not specified. I'll have to take it as to be equal. So H plus ion concentration in oxidation negative is 10 raised to minus 6. So I write it as 10 raised to minus 6. Okay, this is for E oxidation half cell. Now I try to write it for reduction half cell, which is again very easy to write. E for reduction half cell will be written as minus 0.0591 log of by 1. I will write it as hydrogen to the power 1 by 2 by H plus. Why do I write this? The reason is the reduction half cell will function like this. Will function like this. H plus will take up an electron to change into half H2. This will be the cathodic reaction. Okay, this will be the cathodic reaction. तो आगे हम क्या लिख सकते हैं? ये हाइड्रोजन का तो प्रेशर हमने 1 ले लिया. I've taken the pressure of this hydrogen as to be 1. So I will write this thing as E reduction half cell will be equal to minus 0.0591 by 1 log of 1 by H plus. Okay, I have to calculate pH. So for calculating pH, I'll calculate I'll calculate negative log of H plus. देखते हैं what is the answer that comes up. So I will write it like this. What is the E cell? E cell is E for oxidation half cell plus E for reduction half cell. As simple as that. Oxidation half cell, reduction half cell, दोनों को add करके आपको result निकाल देना है. So I will erase this part. So E for oxidation half cell and E for reduction half cell, the sum of that is already given. It's given as 0.118. 118 volts and I take 0.0591 common, this will become log of 10 raised to minus 6 by H plus ion concentration. Log of 10 raised to minus 6 by H plus ion concentration. This will become equal to minus 2. This will get cancelled. This is exactly double of this. And this can be written as 6 log 10 minus log of H plus. Can I write this? Okay, I can write this very easily. So 6 log 10, that is equal to how much? That is equal to 6 log 10 is 1. So ये कितना हो जाएगा? ये minus 2 है, this is minus 2, it will come over here. So this will be equal to 4. Okay, this will be equal to 4. Sorry, yeah, this will be equal to 4 and minus log H plus, minus log H plus. This can be written as equal to pH, which is equal to 4. So our pH for the solution in the cathodic half cell or in the positive electrode turns out to be equal to 4. It's as simple as that. यहीं पे आपको थोड़ा calculation करना है. That's very simple a calculation. Since you are very proficient with mathematics, I guess you will be able to solve this in a blink of an eye. Okay, so let's move on to the next question, which is even interesting. Okay, so in this question, we have to identify something. Let's look at the question. EMF of the following cell is given at 298 Kelvin and also at 308 Kelvin. If the heat of the reaction taking place at 298 is X, what is the value of X by 10? X by 10 के form में दिया है, इसका मतलब ये integer type question है. This is an integer type question. How to solve this? Now, you do not need to write the overall reaction. You just need to remember that delta H for reaction, apart from other thermodynamic properties like delta G and delta E cell, delta H can also be calculated. Delta H is calculated using this equation. Delta H is equal to, please remember, delta H is equal to minus NF E cell minus temperature dE cell by dt. इसको याद रखिए. How this equation is derived? It's very easy to write. There is something known as Maxwell Relation, which says that delta minus of delta G by delta T is equal to entropy change. Okay, so entropy change के लिए मैं delta G की जगह पे मैंने रख दिया NFE. So I will get a relation of entropy in terms of E cell, and this is from where we obtain the final relation. Okay, so delta H turns out to be this. I just have to identify what is the value of N. So it's very easy. H2 changes to H plus. देखिए H2 changes to H plus. Okay, so 2H and must give out 2 electrons. Also Ag plus will change to Ag plus changes to Ag. So it means 1 electron is taken over here, 2 electrons are given out over here. 2 electrons are given out and 1 electron is taken in. So total number of electrons exchanged is equal to 2, not 3. Exchange means 2 is given out, 1 is taken in. So this has to be multiplied with 2 of such reactions and 1 of this will be required. So 2 electrons are given out, and so the value, so 2 electrons are given out, so total 2 electrons will be taken in. None of the electrons will have a free existence. So exchanged electrons will be 2. तो मैं यहाँ पे 2 लिख दूंगा. F की वैल्यू है 96500. E cell is given at 298 Kelvin, that is 0.265. Okay, temperature is 298. DE cell, that is change 0.26 minus 0.265. 0.26 minus 0.265 by dt को हम लिखेंगे 308 minus 298. 308 minus 298. Okay, so this will be 5.005 by 10, so this will turn out to be 5 times 10 raised to minus 4 times 298.265. This value will come as to be equal to, this is a pre-calculated value, I'll tell you the value, what will this value be equal to. आप calculate करोगे तो ये value आ जाएगा 80 किलोजूल के करीब. Okay, this value will come as to be equal to 80 kilojoule. So the value of x will turn out to be equal to 80. हमको निकालना है x by 10, so answer हो जाएगा 8. If suppose delta H comes in, the magnitude is, so we are only bothered with the magnitude. Sign only tells us whether the process is exothermic or the process is endothermic. If you are getting a negative sign, don't worry about it, because integer type question you cannot incorporate a negative sign. You can only incorporate the magnitude of it. So only like focus on the magnitude. Do not worry about the sign. Okay, so with this we move on to the next question. But before moving on to the next question, let me give you a small message that Vedantu doubt solving app is one of the best apps on the Play Store, and we are solving about like 2,000 to 3,000 problems on a daily basis, and there are a number of people who keep coming back for resolving their doubts. So please do install this, and please do post your doubts so that you do not have them while you are studying. So this is one of the best apps on the Play Store. As far as the IIT JEE pattern of study is concerned, the medical entrance examination is concerned, there is no app which parallels the quality that we are providing, and also all the video lectures and every other quality content is at one place. Okay, so with this message we'll move on to the next question. The next question is this: an hydrogen electrode is placed in a buffer solution of sodium acetate and acetic acid in a ratio x is to y. A buffer solution is one which resists the change of pH. So sodium salt of acetic acid and acetic acid are in the ratio x is to y. The oxidation potential value is E1 volts, and if the ratio is y to x, the potential value is E2 volts, respectively 298. What is the pKa of acetic acid if the pressure of hydrogen is 1 atmosphere? It's a simple problem, and let's try to work out this problem. थोड़ा सा लेंदी हो सकता है, लेकिन ये बहुत डिफिकल्ट नहीं है. Okay, so I will solve it in a stepwise manner. How do we solve this question? First we try to identify what will be the relation between pKa and the pH of the solution. ठीक है, pKa and the pH of the solution. Let's see. So pH of the solution, let's say solution 1 can be written as equal to pKa plus log of salt by acid. हम लिखते हैं salt by acid, this is the pH of the buffer equation, that this is what Handerson's equation which we had utilized in ionic equilibrium. So this can be written as x by y. This is for the first relation where ratio is x is to y, and pH2 can be written as pKa plus log of y by x. We can write this. Okay, now let's move on to how do we incorporate potential values into this. So to to incorporate potential values into this, we should remember that in a buffer solution where H plus is present, we can express, see, this is oxidation potential that we are talking about. We are talking about oxidation potential. That means we are talking about a reaction where hydrogen is being converted into H plus. Okay, hydrogen is being converted into H plus. So half H2 changing into H plus gives out an electron. हम क्यों ये रिएक्शन लिख रहे हैं? क्योंकि ये बफर्स के बारे में है और यहाँ पे जो कॉमन लिंक आएगा ऑक्सीडेशन पोटेंशियल ऑफ हाइड्रोजन एंड बफर के बीच में, द कॉमन लिंक वुड बी द H plus ion concentration. Okay, so I will use this to relate the oxidation potential with this equation. Let's look at how do we do that. So I will write this equation, and this equation can be further elaborated as E1, क्योंकि ये लेट्स से फर्स्ट इक्वेशन के लिए लिखा गया, this is the oxidation potential for hydrogen. Oxidation potential of hydrogen is taken as 0, so it will be written as 0.591 by 1, okay, log of H plus ion concentration by H2 to the power 1 by 2. Now it is already said that the pressure of hydrogen is 1 atmosphere. Pressure of hydrogen is 1 atmosphere. तो pressure of hydrogen अगर 1 atmosphere आपने ले लिया है तो इसको हम हटा देते हैं एक बार में. I remove this completely. Okay, why I've directly written this over here? Because Nernst equation is E cell or E of the oxidation half cell plus E naught plus minus 0.059 by N log of hybrid value of Q. Okay, hybrid expression for the equilibrium constant or the reaction quotient. अगर हम E2 के लिए लिखेंगे, then it will also be written as, let's say this is H1, 0.0591 by 1 log of H plus 1. Can I write this? Sorry, 2. This is for the second solution. Okay, for the second solution this is the potential, for the first solution this is the potential. Now minus log H plus, if I include minus with this, what can we write? E1 can then be written as 0.0591 times pH1, okay, and E2 can be written as 0.0591 times pH2. Okay, आपको समझ में आ गया कैसे मैंने ये pH निकाल लिया? And now since I have pH, I will put this over here. So pH1 की जगह मैं ये लिख देता हूं, E1 by 0.0591 pH2, I will write it as E2 by 0.0591. Okay, E1 E2 कितने हो गए? 0.0591, E2 0.0. Clear? Now I'll erase this part. So if I try to solve both of these equations, log y by x, I can write log x, I can reverse this. If I reverse this, it will become E2 by 0.0591, which is equal to pKa minus log of sorry, I take both of these equations and then equate them. So I add both of them, this will become equal to E1 plus E2 by 0.0591 E1 by E2, इसको यहां से एलिमिनेट करने से अच्छा मैं इसको ऐड कर देता हूं दोनों को. ओके, सो आई विल गेट E1 plus E2 by 0.0591, and this will be equal to 2 times pKa, and this will be log of x plus y plus log of y by x. I will include them in the equation. Log of x by y times y by x कितना हो जाएगा? 1. Log of 1 is equal to 0. So pKa turns out to be equal to E1 plus E2 by twice of this, that is 0.118. So our answer should be A. It's easy question, no hassle. Problem थोड़ा आराम से सॉल्व कीजिए. Don't rush through the question. Electrochemistry questions at least take 2 minutes to solve every question. Okay, at least take 2 minutes to solve every question. Clear? So let's move on to the next question. The next question is this, and this is the last question for the day. This is a beautiful question. Which is a better oxidizing agent? K1O4 and dichromate are both utilized as an oxidizing agent, and both are utilized as a strong oxidizing agent. However, many a times what happens, by modulating the amount of H plus or the other species, active species present in the medium, I can modulate the oxidizable or oxidizing nature of these entities. So how do we measure the oxidizing nature? Now, the process or the one which will be a stronger oxidizing agent will behave in such a way that it oxidizes something, generates a value of E half cell, that is E oxidation potential, and the E oxidation potential is higher in value, so that the delta G value turns out to be more negative. So what we need to do is we need to identify what is the delta G value, or how do we or we can only directly compare the E cell for the values. So since this is the we are comparing the oxidizing power, we are only considering the oxidizing power, so only take the half cell. Okay, so how do we solve this question? So let's see, we take the first equation. Now potassium is not important because potassium does not take part in the reaction, and we take dichromate, Cr2O7 2 minus. Since the concentration of dichromate ion Cr3 plus and H plus all are given, it would be best if we balance the reaction. If you know the balanced reaction, it's good and well, but try to balance the reaction also. So you see this question takes cues from redox reactions and balancing of redox reactions as well. So electrochemistry में सारी चीजें आ जाती हैं. In this oxidation state is +6, it changes to +3. So +12 changes to +6, it takes up 6 electrons, and there are 7 oxygen atoms which are excess, so we need to add 14 H plus ion so as to obtain 7 moles of water. Okay, very simple, very easily this can be written. So now I write what is the E cell for this. E for Cr2O7 2 minus changing into Cr3 plus will be equal to E naught, which is equal to 1.33 minus 0.0591 by, what is this value equal to? 6. Number of electrons is 6, log of Cr3 plus ion concentration by Cr2O7 2 minus concentration raised to the power, we are not raising it to any power, but H plus will be raised to power 14. ठीक है, let's put the values. 1.33 minus 0.0591 by 6 log of Cr3 plus concentration is given 10 raised to minus 2 to the power minus to the power 2 will be 10 raised to minus 4 by dichromate 0.1, that is 10 raised to minus 1, H plus 10 raised to minus 1 times 14, 10 raised to minus 14. This will turn out to be equal to 14 plus 1, 15, 15 minus 4. 15 minus 4 will be 11. Can I write this? So log 10 raised to minus 11, sorry, 10 raised to plus 11, because so it will turn out to be equal to 1.33 minus 0.0591 by 6 times 11. This will be the result, log 10 1. Okay, so if I approximate this, let's say we take an approximation, अगर हम इसको 12 मान लेते हैं, if I take this as 12, this will become equal to 2, 12 by 6, 2, and 2 times this value is 0.118, 0.118 or 0.11, this will turn out to be equal to 1.22, almost 1.22 volts. Okay, let's try to work it out for the second one. So for this one I have calculated as 1.22 volts. Okay, let's try to calculate it for the second one in the same manner. So permanganate changes to Mn2 plus. Fine. How many electrons are being gained? 5 electrons, 4 hydrogen, 8 H plus, 4 oxygen, 8 H plus डालेंगे हम, and that will make it equal to 4 H2O. Okay, now if I try to write the Nernst equation for this, I will write it as E cell is equal to E naught for this, MnO4 minus changing into Mn2 plus, that is 1.51. Okay, 1.51. So it is, if it is oxidizing something, it will take up the electrons. So it is taking up the electrons. 1.51 minus 0.0591 by 5 log of Mn2 plus concentration by MnO4 minus times H plus to the power 8. ये होना चाहिए. Let's see what is the result that comes up. So it is 1.51 minus 0.0591 by 5 log of Mn2 plus concentration is 10 raised to minus 2, H plus is 10 raised to minus 2, so it's 10 raised to minus 2 by 10 raised to minus 16, and permanganate is 10 raised to minus 1. Okay, so that turns out to be 17 minus 2, 15. So this will be 15 log 10, so 0.0591 times 3. So this will turn out to be, this can be written as 1.51 minus 0.0591 times 3. Let's see what the value would be. So if this is 6, this will turn out to be 1.8. So 0.059 I'm approximating it to 0.06. So if it is 0.06 times 3 will be equal to 0.18, and 1.51 minus 1.18, this value will be equal to how much? So that will be 3 and almost 1.33. Okay, this will be equal to 1.33, and this value for this I have gotten the value as 1.33 volts. If I've gotten the value which is higher, that means the delta G will be more negative, and if the delta G value is more negative, that means this system permanganate with these concentrations turns out to be a stronger oxidizing agent compared to dichromate. So the correct answer would be the second one. Okay, and with this we finish this session of electrochemistry, and before taking leave I would like to discuss this small message which is very, very important. And this small message says that the opportunities are always disguised as hard work. Okay, so many a times we see that there is a good opportunity in front of us, but it requires a lot of effort, and so while putting the effort we somehow get disinterested and get deviated and get distracted. Like your forthcoming examination is a opportunity and it is disguised as hard work. A lot of people, that is the reason, do not realize that opportunity or any opportunity that you have in your life is or can only be achieved through sheer hard work. So the opportunities are usually disguised as hard work, so that is the reason most of us do not recognize them. Most of us are not able to identify them, and it is imperative that we learn to appreciate the fact that hard work is only going to take us from here to somewhere over here. Okay, for any field, no matter you are musician, you are academician, you are into arts, you are into literature, you are doing something, you're creating something. Okay, everybody has to put a lot of hard work. Nobody becomes like Elon Musk or Bill Gates or like even the biggest minds or the brightest minds and the biggest powerhouses or industrial houses in our country. They have all come from sheer hard work. Okay, so that is the lesson for today. Please start recognizing opportunities as hard work. So when you're putting hard work, you are actually moving towards grabbing an opportunity. So put the maximum of it, put it in a diligent way so that you are seeing a better tomorrow. From today, you're seeing a better tomorrow. Every day I'll keep telling you that struggle is the part and parcel of life. और इससे आप भाग नहीं सकते हो. स्ट्रगल तो करना ही पड़ेगा. हमने भी किया है, आपके पेरेंट्स ने भी किया है, वो आपको भी करना पड़ेगा. Everybody is doing. Some or the other way you'll put a struggle. आप अभी स्ट्रगल नहीं करोगे तो कभी बाद में करना पड़ेगा, बट स्ट्रगल तो करना ही पड़ेगा. Okay, so with this message I take leave, and we'll see each other in the next session for electrochemistry. That will be primarily on electrolytic cells, and I would hope that you revise that topic so as to make the best out of it. So this is Saurav Goswami signing off, and I wish you all the very best. Bye bye.